Previous year NEET questions from organic chemistry. The most suitable method of separation of 1:1 mixture of ortho and para nitrophenols is A. Sublimation, B. Chromatography, C. Crystallization, D. Steam distillation. Ortho and para nitrophenols. Orthonitrophenol, we know, has a structure similar to like this. Sorry. Say you have OH and here you have N double bond O and here you have hydrogen bonding. So this is orthonitrophenol and there is intramolecular hydrogen bonding. Whereas in the case of paranitrophenol, we'll put it like this. Say you have OH here and a no and think of another molecule of phenol here. There will be intermolecular, that is between the two phenol molecules. This is intermolecular. Hydrogen bonding. This is paranitrophenol. So here you can see that in the case of paranitrophenol, boiling point will be very high because there is association between molecules. Whereas in the case of orthonitrophenol, boiling point will be comparatively lesser and this will be steam volatile. That is, it will distill out with steam. So we can opt steam distillation as a method to separate the two. The paranitrophenol will remain in solution, whereas the orthonitrophenol will distill out with steam. So that is a 2017 question. The compound which shows metamerism is. Now, metamerism means same molecular formula but different arrangement of alkyl groups around, say, bivalent groups, like in the case of ethers, then say in COO, then CONH, SO2, etc. A different arrangement of groups on either side of these bivalent groups or polyvalent groups. So let us look at the first compound, that is C4H10O. Now let us see how many possible arrangements are there. It is C4H10O. Then we can have, say, CH3, CH2O, then CH2, CH3. That is one possible arrangement. Next one is CH3, CH2, CH2O, CH3. Then maybe we can write one more like CH3O. Here we'll write CH, CH3 and CH3. See, these are all metamers of the C4H10O. What about this one? There is no bivalent group present in it. So this will not show the property of metamerism. What about C3H8O? In the case of C3H8O, we can write CH3, say we are putting O, and then CH2, CH3. One other possible structure is also similar to this. You will have CH3 on this side, then CH2 you need to write here, O and CH3. That is the same as this. So in this compound also it is not possible. So what about C3H6O? Let us see here. CH3, say C double bond O, CH3. Here also only one possible arrangement. So the first compound, that is C4H10O, that is the one which is showing the property of metamerism. A, C4H10O. That was a NEET 2021 question. Identify compound X in the following sequence of reactions. Here you have toluene treated with chlorine in the presence of sunlight. A compound X is obtained on treatment with water or hydrolysis at 373 Kelvin. You are getting benzaldehyde. So when we look at the product, it is benzaldehyde. Let us see here toluene. CH3 on treatment with Cl2 and sunlight. First, one hydrogen gets replaced, CH2Cl. Then on further chlorination or treatment with chlorine, you will have CHCl2. So this will be, or this has to be, the compound X. That is option B, CHCl2. Why so? This on treatment with H2O at 373 Kelvin, you will be getting CH, and both these chlorines will be getting replaced by OH, and a molecule of water will get eliminated and you will be getting the product CHO. That is benzaldehyde. That is the final product which you are getting. So if we are getting something else here, a different product, you will obtain a different product. If it was CCl3, you might get benzoic acid instead of benzaldehyde. So option B, that is CHCl2, is the correct answer. That is option B.